The learning outcomes and assessment strategies embedded in this Year 2 unit align with the Australian Curriculum Achievement Standards and content descriptors for digital technologies. This sequence of learning experiences aim to develop students' computational thinking of programming and sequencing a code in response to a challenge. Knowledge and skills from other disciplines, including geography and mathematics, are also evident.
Bluebots are an increasingly common technology used in Australian classrooms to teach robotics, coding, and computational thinking. As a progression from Bbots, the key additional function allows students to program code into the iPad app and sync via Bluetooth. Bluebots are an affordable, age-appropriate educational tool that can be used in a range of classroom contexts to integrate technology.
The learning experiences progress from off-computer activities to the utilisation of Bluebot technology for a purpose. The sequence scaffolds the knowledge and skills to engage in the summative assessment task.
This lesson is the first stage of the activity sequence. Within this stage, students will explore directional language in 3 off-computer activities, with the purpose of developing computational thinking in algorithms, sequencing a path, and verbal directional language. Each activity will utilise a grid map. The first activity is named Go Go Stop, in which students are required to discover an unknown path. One student, the director, is supplied with a set of directions to complete the sequence. The remainder of the students must discover the path by taking turns at attempting to complete the sequence. Students must announce each step they take verbally. The second activity is a blindfold navigation in which students in pairs direct each other around an obstacle course. One student will create their own obstacle course by placing image cards around the grid mat. They then lead the other student around using verbal directional language. The third activity is called Find the Treasure. Students split into 2 teams of 2 and stand either side of the grid mat. Teams then roll 2 dice with the commands seen here, and 1 student moves around the mat. The first team to reach the gold wins.
The second lesson in the sequence scaffolds students in transferring their verbal directional language into coding symbols. Students are explicitly taught the types of symbols and their relationship to verbal directions. Students then practice these by representing written directions with symbol flashcards. Their skills are then further developed by directing their peers to a particular coloured grid using coding symbols. This prepares students with the skills for programming a code on a Bluebot without using computer software.
The third lesson aims to introduce the students tactilely to the Bluebots and understand how the associated iPad application can program the Bluebot via Bluetooth. After an explicit demonstration by the teacher, students are provided the opportunity to discover the functionality of each onboard Bluebot input and how the Bluebot moves in response. Students are then directed to utilise the iPad and program directions for the Bluebot to follow paths provided by the teacher, allowing the students to follow their sequence on the iPad. As a final practice, the teacher provides a sequence of locations on the Pirate Island map, 7 Seas, for students to translate into symbolic directions programmed on the iPad. Students develop both knowledge and skill of how to translate previously taught directions into a sequence of steps in response to oral instructions.
The final lesson is focused on summative assessment, where students independently program a route from their classroom to the tuck shop to demonstrate their developed knowledge of coding, computational thinking, and Bluebot technology. The teacher should outline the context and requirements of the task as outlined in the task sheet and criteria. The assessment process is scaffolded for students, initially planning the sequence of steps on a replica off-computer map, then drafting and adjusting the code until successful. Students reflect on their learning using De Bono's 6 thinking hats.
Overall, this sequence develops computational thinking and coding through designed learning experiences. Students have the opportunity to explore all 5 elements of computational thinking: abstraction, generalization, algorithms, decomposition, and debugging. This is evident through the sequencing of a path using directional and symbolic language, recognizing instructional errors within a set of operations, and discerning relevant information from arbitrary. When engaged in this learning, students acquire necessary skills to create an algorithm in response to a purpose. There are multiple opportunities for students to practice their coding skills by applying the knowledge in different contexts.